All right, welcome to the 1.2 set. This video should be pretty short, just to kind of get the point across. I am going to cover number 11. We did some Q&A on 1.2, and basically the discussion was we were just comparing linear versus quadratic. If it's linear, y equals x, y equals mx plus b. If it's quadratic, y equals x. We look at a table to determine if it's linear or quadratic. If it has a constant first difference, it's linear. If it has a second difference, it's quadratic. And those were those two equations, the y equals x and the y equals x squared, were our building equations, if you will, the foundation for building certain equations. So again, I'll answer any questions of that if we need to. But I want to cover the set. I want to talk about that. I want to start specifically with question number 11. Now, the directions say calculate the area and perimeter. So at the top of your page, I want you to write the formula for area. So think a second, what is the formula for the area of a square, a rectangle, anything like that? Hopefully you say length times width. Perimeter. How do we find the perimeter of any figure? If you need to, pause the video a second and think, how would I find the perimeter? The generic way to find the perimeter, hopefully you paused it, basically was add all sides. Make sure you write these two at the top of your paper. If you're watching this video, pause it, write those two at the top of your paper. If I don't see that at the top of your paper, I'm docking points. Because I told you, write it at the top of your paper. Now, what we're going to do is we're going to physically write out a problem. We're going to show our work, novel idea, related to this particular problem. And we're going to start with perimeter first, because that's what they ask. Well, the first thing I want you to do is ask yourself a question about this figure. First of all, what type of figure is it? Well, yeah, it's a rectangle. What do you know about rectangles? What I know about rectangles, and kind of had to pry it out of some classes, is that opposite sides are equivalent. So I'm going to label this side b plus 3, and I'm going to label the bottom a plus 5. Now, why would I want to do that? Because it gives you a visual. You can physically see all the sides now. You don't have to guess at what they are. You don't have to pause and think. You now know. Now, perimeter. How do I find the perimeter? I add all the sides. So I'm going to start at the top and I'm going to work my way around. A plus 5 plus b plus 3 plus a plus 5 plus b plus 3. Again, showing my work. Top, right, bottom, left. Simple. Add all the sides. In this particular exercise, all of your answers will include a variable. Every single problem. Combine your like terms. A, two A's. I've used those. I just mark off what I've used. That's something I do. B's. Where's my B's? I have two B's. So it's plus, because it's plus in between, plus two B's. And then my constants. 5 plus 3 is 8. 8 and 5 is 13, plus 3 is 16, so plus 16. Can I combine any like terms? No, these are not like terms. That is my answer. 2a plus 2b plus 16. And I circle, box, something of my answer. There it is. All right, so that's perimeter. How about area? I had students that get confused about area. I don't know why we get confused about area of something. Area is length times width. Which one do you want your length to be? Which one do you want your width to be? Label them. Length, because if I label a plus 5 length, b plus 3 is the width, or vice versa. Well, what do I do with a plus 5 and b plus 3? I multiply them. Nothing in the middle. Up here we had a plus in between. Here, we're multiplying, because that's what the formula tells me to do. All right, so how do I do this? You double distribute A times B and A times 3. Well, what's A times B? How do I write A times B? Don't overthink it. Just AB. That's A times B. A times 3 plus 3A, because it's a positive 3A. Then I got to go ahead and distribute that 5 to the negative 3. So 5 times b is plus 5b. Make that a 5. And then 5 times 3 is plus 15. Can I combine anything? Do I have any like terms? This is one of the rare cases where no, you do not. This is one of the 5 percenters. There is my answer right there. Okay? Some of you all, just to finish kind of what we're looking at too, some of y'all are getting confused when you combine some terms or look at things. I'm just going to cover some things here real quick. X plus X. If I'm adding, X plus X is 2X. If I'm multiplying, some of you are getting confused on this. X times X is not 2X. X times X, we condense that down into X squared. The exponent tells me how many X's I'm multiplying together. So, think of this. If it's X times X times X, what does that equal to? Think about it a second. Hopefully you said X cubed, because if you did, that's correct. Another couple of things I'm going to comment on. What if I said 3X times 5X? I just used these examples the other day. Multiply your numbers first. 3 times 5 is 15. I have 2 X's, so I have to account for them. X times X, same thing it was up there, X squared. What if I said 3X times 5? This is 3 times 5 is still 15, but there are not 2 X's. I only leave 1. It is not X squared. You have to pay attention to that number sense stuff. All right? It's making you think, but you always want to try and condense things down as quickly as possible. All right? Ask questions if you need to. Be ready for next week.